So mark yesterday. Just a handout. Guys, so start doing question 1. The formula that you need to use to do question 1 is this one here. This is the formula I gave you guys on a couple of weeks ago, I guess. Yeah, about 2 weeks ago. If you look at the notes, this is the formula for the quantile at probability P. So you try to use this formula to do question 1. Question 1, please. Hi. Alright guys, so question one is just a matter of using this formula which I gave you in the notes, sorry, in the review session. So let me show you, if you haven't done it, I know some of you have already done question one. So if you haven't done it, let me show you how to do this, okay? So basically you need to use the formula like, so for instance, the question is to find the quantiles at p equal to, at these points, right? So for example, if you take p equal to 0.1, we know that n is the number of data points, which is, there are 25 data points. So r, using the formula for r, which is p times n plus 1, so it's going to be 0.1 times 26, which is 2.6, right? And the integer part of r is the integer part of 2.6, which is 2, right? So if you apply the formula which I just showed you a minute ago, the formula is this one here, guys. This is the formula you need to apply. So if you apply this formula, you will get the second smallest observation plus 2.6 minus take away 2 times this is what you will get, right? I mean, by the way, the data are already in the arranged form. So they are already arranged from the smallest data, which is this one, to the largest data, which is 16 point this, right? So x2 is this guy here, and x3 is this guy here, right? And if you sub in the numbers and do the computations, you will get this. So the 10th quantile or quartile is 0.475. What it means is that about 10% of the data points are below the 0.475. And similarly, you can compute, so if you want the first quartile, remember first quartile corresponds to 25%, right? Okay, so you do the same thing. So R in this case is going to be 0.25 multiplied by 26, which is 6.5, right? And the integer part of R is going to be 6, right? So Q at 0.25 is going to be right? And if you work this out, you will get 2.1055. So this is how you compute the Q at 0.25. And similarly the other ones. I'm not going to do them, I'll just write down the answers for the other ones. I'm sure you already done it. So Q at 0.5 will be 2.8957. And so this is the median, and Q at 0.75 will be 6.15, right? And Q at 0.9 will be 14.53384. So by similar calculations, so I'm sure you know how to. I'm sure you would know how to do them, right? There's no need for me to. Yes.
In the exam, will all the numbers be arranged from smallest to largest?
Well, I cannot say yes or no, but yeah, if it is like 25 numbers, then it will be arranged from the smallest to largest.
Okay.
But if it is like smaller numbers, like say 10 numbers, then it shouldn't be a problem for you to arrange them from the smallest to the largest. Yeah. Okay. All right. So, and there's one more question, guys. The question's asking you to deduce whether the data sampled from a symmetric distribution or not. Now remember, for a symmetric distribution, one property of a symmetric distribution is that if the distribution is symmetric, then you would expect, in terms of quantile, you would expect the distance from the median to the first quartile to be equal to the distance from the third quartile to the median. Right? Remember the box plot. Remember the box plot has all these 3 points: the median, the first quartile, and the third quartile. Right? And these two distances will be equal if the distribution is symmetric. Now, using the numbers that we computed, this guy here, it turns out to be equal to 0.7902, and this guy here turns out to be 3.2453. Right? So, and clearly these are not close to being equal. So what this means is that the distribution is not symmetric. Okay? Because if it is symmetric, you would expect the distance from the median to the first quartile and the distance from the median to the third quartile to be equal. Yeah. And in this case, they are not even close.
Do they have to be equal to a certain number of decimal places, or exactly equal?
Not exactly, like say approximately equal, right? Say 1.2 and 1.3, for example. That would be close. Yeah. Okay. All right, guys. Can you do question 5, please? Now, question 5. Any question? By the way, any questions on question 1? Question 5 is this one, which you don't have. Just let me announce. Yeah, the 5-number summary here. It says the 5-number summary means the minimum, the first quartile, the median, the third quartile, and the maximum. Right. So let me write it down. So it's the minimum first quartile, which is Q1, then the median, then the third quartile, which is Q3, and then the maximum. So this is the 5-number summary. As you can see, there are 5 numbers here, right? Okay. formulas are the same. And this may be easy to confuse afterwards. Alright guys, so let's see how we can do question number 5, right? The first part is, it's just basically what we have already done. So the first part is what we have already done is question 5, part 1. So we want to find the minimum is obvious, right? The minimum is the smallest, which is 31, right? And the first quartile, which is Q1. So to find that, you're going to use the formula that I showed you earlier, right? So your P is 0.25 and your N is 18. So your R is going to be 0.25 times 19, right, which is going to be, if you work it out, it's going to be 4.75. So R prime will be 4. So Q at 0.25 will be X at the fourth smallest data point plus 4.75 minus 4 times the fifth smallest data point, take away the fourth smallest data point, right? And if you do the calculations, this will be 69.75, right? So that's the first quartile. Now the median is, you can do it in the same way, or alternatively, since there are 18 data points, to find the median, 18, remember, is an even number. So remember, for when you have an even number of data points, the median is the average of the two middle numbers, right? In this case, the two middle numbers are this one and this one, 77 and 79, right? Are the two middle numbers. So what you do is 77 plus 79, and you divide that by 2 to get the median, right? Which will be obviously equal to 78. So this is the median. Yeah. And then the third quartile, I'm sure you can do this, so I'm not gonna, you can do the calculations for this, and you will get 87.25. And finally, the maximum is the largest data point, which is 94. So this is the 5-number summary. So when I say 5-number summary, it's the minimum, the first quartile, the median, the third quartile, and the maximum, right? We also want to compute the interquartile range. Remember, the interquartile range, remember, I defined that in the class, is the difference between the third quartile and the first quartile. So if you take the difference between this guy and this guy, you will get this to be 17.5. So this is the interquartile range. So that's part 1. Now part 2 of the question is asking you to plot a box plot. Now I explained to you what a box plot is in the class, right? I think a week or two ago. Now using these numbers, these 5 numbers plus the interquartile range, you should be able to draw a box plot. And if you do that, I'm kind of cheeky, I've done it already using the R program. You can do this in R. So this is what you should get. Is it this way or this way? Sure. I think this way is better. I think. Oh, maybe this way is better. Which way you want? So this way is better to you, I guess. I don't know. So this is part 2 of question 5, right? So you can see that this guy here is this is the median, which is worked out to be equal to 78. So this guy here is 78, right? Right, and this guy here is the first quartile, which we got to be equal to 69.75. You guys okay? Yeah, and this guy here is the third quartile, which we got to be equal to 87.25. Okay? Right? And then there's, just give me a sec. Then there's something known as then you need to take right, you see what I'm doing here? I'm taking 1.5 times IQR, right, from the lower quartile, right? And this line here, this line is known as the lower fence. This is known as the lower fence, and this, if you take 1.5 IQR from this, right, you will get this to be equal to 43.5. So this point here is 43.5, right? And similarly, Similarly, you should take 1.5 IQR from this all the way outside of the visualizer, right? You will get to this line here, and this will be the upper fence. This is the upper fence, right? And this distance is 1.5 times IQR, right? And the value of this will be 113.5, right? Are you guys with me or not? Hello guys, are you good? Now this guy here, this is known as this one here is known as the upper adjacent, this is known as the upper adjacent, which is the largest data that is less than the upper fence, right? So in this case, the upper adjacent is equal to the largest data in the question, which is let me look at it. This 94, yeah. So this guy is 94. Yeah, and similarly, this guy here is known as the lower adjacent. Okay, this is known as the lower adjacent, and this is the smallest data that is greater than the lower fence, right? And in this case, this is equal to, if you read it, this is equal to 63. Right.
Hang on.
Yeah.
You know the hotspot, you missed out the data points 31 and 42 in it. Lowest you played one.
Those are, I mean, anything that goes below the lower fence is an outlier, right? And so these 2 points are outliers. These 2 points, which are equal to, let me work there. Yeah, 31 and 42. So this is equal to 31. This is equal to 42. They are outliers because they are below the lower fence. And similarly, if you have any data points that are above the upper fence, then they are also out. In this case, we don't have any data points that are above the upper fence, right? So we don't have any outliers there. But we have 2 data points that are below the lower fence, these 2, and they are outliers. Is that clear, guys, or not?
Yes.
So I know it's kind of messy doing a box plot, but you need to get all the points correct. So you need to do the lower fence, the lower adjacent, the first quartile, the median, the third quartile, the upper adjacent, and the upper fence. Right, so these are any questions, guys? So that kind of says, right? All right. Now continuing with the question, there is a question about. You should read. Okay, you should go back to the question. It's asking you, what does a normal distribution look a plausible model for data? What can you say about it? I mean, is it yes or no? I mean, looking at this picture here, can you see that a normal distribution is plausible or not? And if yes, why? Or if no, why? Remember, a normal distribution is a symmetric distribution, right? So the question is the distribution, is it symmetric? I mean, looking at the box plot, can you see if it is symmetric or not? Come on, guys, wake up. Yes? Because remember what I said, if the median is about halfway inside the box, then it's kind of symmetric, right? And the median is what? Is the middle line, and this is the box. So if it is about halfway, then the distribution Yeah, you follow me? Because you say, I mean, looking at a box plot, you should be able to say immediately whether a data is symmetric or not. All right? Just look at the middle line and how it compares to the two quartiles, right? That's all you need to do, right? Okay, now part three of question number 5. Yes?
In the example, will we give them like a graph paper to actually get the box plot?
Not sure, but I can find out. Well, I don't think you'll be asked. There will not be a question on box plot. I have already set the exam for you, so I can tell you that there will not be a question on box plot.
Okay, thank you.
Maybe you're happy with that or not. I don't know. Right. Question 3 is asking you to compute the mean and the variance. Look, calculate the sample mean and the sample standard deviation. Right? So, I'm going to do this quickly because I'm sure all of you know how to the sample. Remember, the sample mean is just what you do is you add up all the data points, yeah, and you divide by the number of data points, which is 18. So if you do that, you will get 75.06. Now, for the sample standard deviation, there are two formulas I gave you in the notes. I would use the unbiased version, but if you use the biased version, you still get the full mark, right? So remember, the unbiased version is this one here. This is the unbiased version of the sample standard deviation. Yeah. You remember or not? Yeah. Okay. Now, if you work this out, just to save time, this will be 16.54. If you work it out. Okay. So, and remember just to recap, the median, which was equal to 78. So this is 78, but the mean is. Remember, if another property of a symmetric distribution is that the mean and the median should be approximately equal, right? But in this case, the mean is 75.06, but the median is 78. So they're not really close. But the reason that they're not close is because I will explain why they are different. I mean, they are so different. It's because of this picture here. Look. You see, you have these two outliers, yeah, and these two outliers have the effect of reducing the mean, right? But they don't affect the median, but they do affect the mean, right? When you have an outlier, right? So because of these two outliers, the mean has been pulled down to 75.06, right? Okay. So this is what I will say. The mean is affected by the two outliers. All right, guys. Are you okay or not? You follow me. So this completes question 5. Can you do the next one, please? Question 6. Question 6 is this one here. So the first part of question 6 is from probability 1. I'm sure you did that last semester, right? You should be able to do that. You don't know the problem. Okay guys, so let me show you. If you haven't done, I know this is stuff you should have remembered from last semester, not long ago. So let's try to do question 6, guys. Shh. Question 6, part 1. Right. Now we are assuming that x is a normal variable with parameters, with these parameters. Now we want to find the CDF of x. Remember, what's the definition of a CDF of x? Is the probability what? The probability that capital X is less than or equal to this, yeah? So now what I'm going to do is I'm going to do this on the both sides. Now one of the properties I gave you, if you look at the stuff I did last Friday in the review session, one of the properties that I gave you is that this guy here has the standard normal distribution. Do you remember that or not? If you do not remember, please look at the properties of the normal distribution. You might have even covered this in probability 1, I don't know. So now this is phi. No, phi here denotes the CDF of. Alright, so that's part 1. Now part 2, is that okay guys? Part 2 is asking you to find the quantile function for the normal distribution. Now remember, again from stuff that we did last Friday, I don't know if you remember or not, the quantile function QP is defined by this. I think I mentioned this on the review during the review session on Friday. I think it was last week. Okay. Anyway, so this is the definition of a quantile function. Is the Q of P, which is the quantile function, is defined as a thing that satisfies this equation, right? So this implies that phi okay, and this implies that okay, and this implies that Q of P is mu plus sigma times, right? So this is the quantile function of the normal distribution. Now the question in part 2, we also need to find out the interquartile range. Remember the interquartile range, remember, is the difference between this and this. Yeah, that's the definition I gave you, right? So this is going to be mu, mu plus sigma phi inverse 0.75 minus mu in brackets plus sigma phi inverse at 0.25. Okay, so these two guys will cancel, so you get sigma sigma in brackets alright, this is what you get. Now you can read these two numbers from the normal table, which I showed you briefly. I mean, it's in the videos. I mean, if you look at the videos, you will see how to read this guy and this guy from the normal table. And if you do read them, you will get this to be equal to approximately 1.349. Okay. Alright, so the IQR for the normal distribution is 1.349 times sigma, which is sigma is the population standard deviation. And sorry, just a minute, I'm running out. But in practice, you need to estimate sigma by the sample standard deviation. So an estimate of this is S, where S is the sample standard deviation. Alright guys, okay, so that the third part I will leave. I mean, there's also part 3, which is basically asking you to compute this for question 5. Right, I will leave that for you to do. Right. The full solutions to all the questions, you can find them on the course website. There is the video solution, there's a typed solution, and there's also a handwritten solution. So there are three forms of solutions to this tutorial sheet, all on the course website. Okay. See you guys. Thank you, ma'am.
Some of these questions, how much? Yeah, I didn't know I was doing questions.
See you.
Thank you.
Yeah, thank you, man. Take care.
Sir, can I ask a question?
Yes.
How do we find the number